Hello, a short discussion of rounding. So on the internet there's a website that will tell you or claim to the exact population of the UK. So apparently the UK population right now is exactly 66,743,507. Now this is wrong. This is very clearly wrong. No one knows this. We don't have a real-time instant record of births and deaths in the UK. So it's a bit silly to give this level of accuracy because this figure is wrong. However, we can be fairly sure that the population of the UK is about 67 million. That is correct. That is accurate. You can verify it from any number of sources. So what have I done? I have rounded this silly number which is wrong. It's too accurate. It tries to be too accurate to this number which is accurate and sensible. I mean, no one needs to know the exact number of the UK population. Knowing there's about 67 million is enough for most purposes. What if I want to be a tiny bit more accurate? Well, I could say it's 66.7 million, give or take. I could take some more numbers and I could say 66,744,000, give or take. So let's just have a little look at some of these numbers. Why have I said in the first place it's about 67 million when the number started 66,700,000 and something? Well, the reason is this. If I count in millions, if I have here 66 million and here 67 million, and I count up in between, then sort of halfway in between, I get 66.5 million. In other words, 66,500,000. So the UK population of 66,743,000 and some stuff is about here. In other words, it is closer to 67 million than it is to 66 million. So what I've just said is it's approximately 67 million. That's the idea of rounding. There we go. Very simple. A little bit more detail in terms of what they might ask you in an exam and how to go about doing it and using it. Well, how could I have asked you for this level of accuracy? What I would probably say is to the nearest million. So this number is the UK population, correct, accurate to the nearest million. This number is the UK population to the nearest, think about it, what am I going to write? To the nearest 1,000. Okay, because here I've got 3 zeros like 1,000 does, and this is the nearest 1,000. Why? Well, because the same discussion, here I have 66,743,000, but 507 is just a tiny bit over the halfway point. It's closer to 744,000 than 743,000. If it was exactly the halfway point, by the way, at 5, then you'd be rounding up. And why? Because of this reason here, that it might be like 507, just a bit more. So you're rounding up always if you see a 5. Okay, so another interesting example to get to grips with this. Let's just say I have the number 39 and it says round to the nearest 10. Hopefully that's really easy for you. What do I mean by the nearest 10? Well, it's a number ending in 10, so I'm thinking about 30 or 40, and you can go ahead and look and say, oh, it's closest to 40. If I said 32, rounded to the nearest 10, that's going to be closest, 32, rounded to the nearest 10, that's going to be closest to 30, not 40. And as we mentioned earlier, if I said 35, rounded to the nearest 10, well, that one, it seems like it's halfway exactly between these two. So we just have this agreement, as I mentioned above here, that 5 is going to round up just in case there's some extra small numbers here. So it's going to be rounding up to 40. Hopefully that's enough of an idea for the ones where I'm rounding to the nearest 10 or the nearest 1,000 or the nearest 100. We do also have to mention what happens with decimal numbers, where I might round to the nearest 10th or 100th. So here is everyone's favourite really fun decimal number. 3.14159265358979323, going on forever. I don't know the rest of the numbers, but this is this super famous number called pi. And we love pi because it lets you work out stuff like the area of a circle. But anyway, this is too long. Really, no one cares about all these numbers down here. They don't matter that much, okay? All we care about is that pi is about 3.14. Really, that's all we normally use, all we normally care about. So my instructions here were easy. Round to the nearest 10, that kind of stuff. How do I tell you that I only care about these first three numbers in this crazy long, infinitely long number called pi? Well, what we normally do is we talk about this. We say 3SF, and that stands for 3, obviously, significant figures. 3 significant figures. Basically, check it out, I've kept 3 numbers. 1, 2, 3 numbers. So if you have a question that wants you to round to 4 significant figures, you'll keep 4 numbers. 3.141. 0.14. And I said 1, but I actually am going to write 2. Why am I going to write 2? Because this 1 is followed by the number 5, which means actually we're going to be closer to 3.142, just like we discussed here. 35 is technically, we say, closer to 40 than 30. Okay, what if I said 5 significant figures? What if I said 6 significant figures? What if I said 10 significant figures? Pause the video for a moment and see if you can work them out. So 5 significant figures. 1, 2, 3, 4, 5, that's there. So I need to write down 3.141, and then I look at this. The 5 is affected by the next number, the 9. It rounds up to therefore be a 6. Done. 6 significant figures. 1, 2, 3, 4, 5, 6 numbers, so I stop here. Okay, so I'm going to have 3.1415. I'm looking at the 9. It stays a 9 because the next number is just a 2. It's a small number next, so it's closest to 3.14159. 10 significant figures. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that ends here. So I'm going to have 3.1415926, and I'm looking at this 3. It's affected by the number afterwards, which is a 5. 5 rounds up, so that 3 is going to actually be a 4 for the closest approximation that I can get to 10 significant figures. Great. That's more or less all I have to say, except that there is another way of counting. So let me do that over here actually. This is called decimal places. Okay, so what if I said I would like to know what pi is, the accurate answer to 2 dp, which means 2 decimal, like the decimal point, places. That's the word places. So what do I do there? I have a look and I count and I say, okay, here's the decimal point. 1, 2 decimal places is the number 3.14. Stays at a 4 because it's a 1 afterwards, so 3.14. If I said 3 decimal places, then I'm looking for the decimal point. Count the numbers 1, 2, 3. So 3.141. Look at the next number, which is a 5, and say it means it rounds up. So I have 3.142. 3.142. Notice there are 1, 2, 3 numbers after the decimal point. Next one. Let's try 4 decimal places, let's try 5 decimal places, and let's try 10 decimal places. So Pause again and have a go yourself. 4 decimal places. Decimal point, 1, 2, 3, 4 numbers. That's the last one there. Should it stay a 5 or should it go up to a 6? Well, 9 comes next, which pushes it up to a 6. So 3.1416. 5 decimal places. 3.12345. So it's a 9 is the last number. Does it stay a 9 or does it go up to a 10? Well, 2 is the next number, so it stays there. So 3.14159. And 10 decimal places. Decimal point, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 is my last number. Does it stay a 5 or does it go up to a 6? 8 comes next, which pushes this up to a 6. So 10 decimal places, 3.1415926.536. There we go. And we can compare and say in this case, 3 significant figures is the same as 2 decimal places. Why? There are 3 numbers there. There's 2 numbers after the decimal point there. So 4 numbers there, 4 significant figures. 3 numbers after the decimal point, 3 decimal places. They're all the same, they're all the same. This here is obviously going to be different because I've said 10 significant figures and 10 decimal places, and they're not the same thing because we've got this extra digit at the front. Notice this relationship is not always the case. For example, if I have a 431.25, 431 and a quarter. Let's suppose I want to do that to 2 significant figures. And let's suppose I want to do it instead to 2 decimal places. So let's have a look at what happens there. Pause and have a go. Okay, 2 significant figures, I get to keep 2 numbers. They're the 4 and the 3. 1 means it's very close to 430. I've just kept 2 numbers and a 0 to hold them in the right place. That is 2 significant figures. 2 decimal places, I start counting the decimal point. So I've definitely got 431 point, and then 2 decimal places, I get the 2 and the 5, and that's it. So these are very different things now because there's more digits in front here. If I wanted to have 4 significant figures or 0 decimal places, I can do them as well. Pause and have a go. So my last 2 examples, 4 significant figures. I want to keep 1, 2, 3, 4 numbers. So that's going to be 431 point. And after the 2 comes a 5, so that makes it round up. So it's going to be 431.3. 0 decimal places. Well, I'm not allowed to keep any decimal places, so I've just got 431. The 2 comes next, so it stays at 431, does not round up to 432. So there you go. That is my final example. 0 decimal places. There are no numbers after the decimal point. I mean, you could probably put 0.0 if you want, but that's a bit silly. So there we go. Have a lovely day.